Okay, welcome back. My name is Valentina. Up next, we have Sumit Saha, a software engineer at Microsoft. He will share his knowledge on architecting enterprise by showing how to build an intelligent document Q&A system, Java, Spring AI, and RAG. Sumit, the floor is yours.
Hi.
Hi everyone, thank you for joining the session. My name is Sumit Saha and I am working mostly as a a backend developer engineer, and I have quite experience in developing AI-based systems. And I have around 5 years plus experience. I worked in different large companies and mostly in backend and AI based systems. So today I am going to do some presentations and workshop on building an intelligence document system. We'll mainly use Java, Spring, and AI. And this session will have mainly some presentation, learning about some uh, Java, Spring AI systems, some LLMs, and then we will also do some hand-on coding for our the workshop. So we can start that, and let me share my screen actually. So today I will try to use my enterprise knowledge to build an intelligent document question and answering system with Java, Spring AI, and RAG. So basically, we will discuss about some LLM foundation and key concept that will require for us to understand the project and AI and everything for things. Then we will also get introduced with RAG, that's called retrieved augmented generation, which is a very important for nowadays for any kinds of AI-based product. And then we'll deep dive into that systems and RAG architecture. Then we'll take a look on our stack and technology, and we'll do some coding. So this is actually about myself. I'm currently working on M365 Teams. I work in Microsoft, mostly in Microsoft Teams and backend teams. And I have a quite experience in Java and AI and RAG innovative. So first of all, starting about building an intelligent document system, we need to understand first what is an intelligent document systems, or in short, we can call it IDS. The intelligent document system is a software that can understand, process, exact, and answer question from document using AI, machine learning, natural language processing. And what is the difference with the traditional document system? Traditional document system cannot understand what the document is doing or what the documents means. It can only do some searching or anything. But an intelligent document system can react like a human. They can read the document, they can understand the document, they can understand the content. So how basically is system work, intelligent system works? Like we have to give a set of documents to that IDS or IDS internet document systems, and it will read that documents and will process for us, or it will answer some question. We can have it, we can it can process the document for us, or it can understand the documents. The documents we generally provide could be in different formats. It could be PDF file, Word file, different kinds of documents. now we need to understand that there is LLM, like traditional LLM and RAG. For the intelligence document systems, we always mostly use RAG. So we have to firstly understand few concepts like what is the LLM, traditional LLM, what is the RAG, and how RAG is different than the traditional language model or traditional LLM, what we can solve or what we achieved by using RAG. So I will deep dive them into one by one. So in traditional LLM systems, we train some model and using some data, it can work on only that's trained data. It does not have any external knowledge. Its knowledge is fixed and it can be outdated. What I mean by them. So we know different types of traditional LLM model like ChatGPT, Gemini, or different things. Or we can build our own LLM model. All those LLM model has a fix. Let me share. So how that traditional. So we have a what is the traditional LLM? We could have a machine learning model that's we call LLM. It's uh, it's we need to train some data always, and it's learn. So we always use some traditional some data, and once we train, it can only work on that. Suppose I am training my traditional LLM and I have the data up to November 2025. So my LLM can work knows about everything till November 2025. It does not have any knowledge about uh, the like it will not update it with the new data and everything. So let's understand more about the LLM. Let's try to understand more about the LLM. A large language model, it's an advanced AI model trained on massive amount of text data that can understand, generate, and reason with human language. So LLM basically an AI model that's we trained it with a massive amount of text data and it can understand easily those and generate and reason with human language and it can interact with human easily because it can understand the human language. Actually, how it works, it predicts text using pattern learned from billions of sentences. LLMs used in mostly chat box, search system, rack systems, documents, QA, and different purposes. We use LLM, and LLM is very powerful. It has data, it has training data, and it can work very well on that. Some LLM example, if we see that's OpenAPI has Chat GPT 4, GPT 5, Google has Gemini, and Microsoft has 5.2, 5.3, and there are also some open source. So which LLM has more training data, that generally performs better. So if we want to understand what is the extent of LLM. So LLM have the extreme capacity in reasoning, summarizing, and understanding natural language. It can understand human language very easily. It can generate high quality text. Like we can write our daily different types of things like email or any answer. It's write very good quality of context, the power of LLM. It can summarize long documents. It can translate it, understand multiple languages. And it's quite easy to use. We can have some question into the chatbot and it can answer. So LLM is a very powerful tools for everyone. So How actually LLM works? Basically, LLMs turns text into token, understand their meanings, and predict the next generation to response. So, what is tokens? Like LLM takes any words, it's break down the sentence or words, it's generate have some algorithm, and using them, it generates convert that text into some token, and these tokens are used for the processing. So in this diagram, we can see in LLM, we generally type something. So I'm the user or anyone the user, it puts some input text. The text is done tokenization. So the text is breaking into a small chunks, and every chunks is embedded and given into some number. We'll discuss then it later. And this is called tokenization. And then it's sends to the processing, and then processing this token, LLM provide the output. So the output is generated. Again, de-tokenization is done. Like the token is again generated to sentence, and the response is sent to the users. This is the how overview of the an LLM model works. Now we need to understand the limitation of an existing or LLM model. So LLM is doing a lot of things for us. It's doing very nice work. It can understand the human and everything, but it has some limitations. So the limitations are could be like hallucination. Sometimes LLM make answer when they are unsure. Like we know that every LLM has some known has some training data. So if we ask something to the LLM that's not LLM is not trained yet, it hallucinate. So if I suppose I have the weather information till October 2025, and if I ask some information to the LLM about the weather information of November 2026, the LLM will be hallucinate because it has no idea about the uh, it's not updated with the data of the November. So it could hallucinate. The hallucination means it could give some uh, wrong informations, or it could try to answer intelligently but with some wrong some invalid answers or anything. So that's the problem then there is another, they don't know about some things. So I wanted to like added some of my information, like if they cannot adopt my informations and update, like in LLM the informations are only their training data. uh, they don't know about the new data or policy. I can go for an example here. So this is, I have an LLM model, and I suppose I have trained this LLM model. I have trained this LLM model. I'm calling this train data. Suppose and I am trained with the general informations, all the informations. Now I have a company. Suppose my company has some privacy and some law and some company policy. So suppose I have some policy in my company, and if I want to use them, actually my LLMs does not have any idea about those policies. So if I ask any question to the LLM about my company policy or any steps, the LLM is completely unknown about it. It cannot read these documents or cannot update itself by own. So it has this limitation. It knows only about its trained data. It does not know it, it does not know about anything. I can consider it's a very smart person, but it has a limited knowledge. It has a uh, fixed knowledge base. So uh, and short memory. In many cases, the LLM forgets about that previous data, and LLM also has some issue about proofs. LLM shows the data, but it cannot show where the answer come from. It could be random or it can be anything for its unknown data. And it's not an like a domain expert. It's have its own training data, and this training data like in GPT-4 or anything, those training data are general training data. It does not it cannot it's behave like a general uh, person who understand everything from like a common purpose. It does not have any expertise on any specific field or anything. So now come to the points how we can make this system intelligence. Here, how we want to make it intelligence. Intelligence means like I have a company. Suppose I have a company and I have some company policies. I want that's my document intelligence systems or my AI model or my LLM knows about my company policies and use it with its knowledge base, so that I can use them properly. And that's LLM model. So here comes in the picture RAG. It's retrieval augmented generation. It's make an LLM more intelligence, accurate and knowledge without needing any retain. So what is actually that's retained LLM? Like when LLM has its fixed model, trained data, and it's trained. But whenever I want to use it for my company, one of the possible solutions could be I could train the LLM using our company data, and it will be intelligence and it will know about my company policy and everything. But that's not going to be a easy task because it's costly and the company policies and everything was changes quite frequently. So it's not an optimal solution to train the LLM models like again and again because it's quite expensive. So the RAG comes into the pictures. What RAG does? RAG uses the LLM model plus our knowledge base. So RAG means an LLM intelligence by letting it search the real informations before answering. It retrieves the related data or documents, and the LLM uses this data to generate accurate answer generations. So if I go back to here, actually, so I have some policy and LLM does not know. So when it's come to the RAG, what it do, suppose I am considering RAG is another element which where I send the our company policy to the RAG. RAG takes this it's talk with the LLM, and then it generate response. So before I was asking LLM was not about sure about this policy. Now the RAG coming, the RAG takes the our company information policy, and it's update the LLM, like it's tell LLM about the policy and everything, and now the LLM can generate better answer for me. Now the LLM has this LLM does not have any idea about this policy, but RAG introduced this LLM with the new policies or new data, so the LLM can work as an intelligent person. So it's what happening, that LLM is an intelligent person, but it has some um, limited information or limited data or limited knowledge. Now the RAG is coming and giving the LLM some more context or informations, and then the LLM is performing as an updated person, or its knowledge base will be enriched, so it can have a uh, uh, it can respond about those new added data or those policies. And now we'll see how details the RAG works and how it happens. As I mentioned, that's one of the solutions could be training the LLM model with the new data, but it's quite expensive. So this RAG comes here, and RAG solves this problem mostly. So RAG, retrieval augmented generation, is a technique where LLM search your documents or database for relevant information before generating an answer. Instead of guessing, LLM retrieves the real data and used to produce up-to-date and context-aware response. So if I go here, actually how this RAG's coming into pictures. I have an LLM model, and before I user was querying here. So it's user, and it was generating me response, and the response was based on only the LLM trained data. It knows only LLM trained data. Now the RAGs came into the pictures. So here is the RAG. Suppose here I have some documents and doc. In the first picture, I'm doing some request, and the LLM is giving me the response, and I have some documents or some knowledge base, but the LLM does not have any idea. It was not using that document to generate the answer. So LLM does not know about these documents. Now, when the RAG coming, what's happening? The user is making request to RAG. Here's the RAG is coming in the pictures. The RAG is querying the documents, taking information from the documents, and then it's sending request to the LLM with what it's getting from documents. It's generating the response and sending to me as a response. So Now the LLM is, so what is happening in that? Now the LLM is getting this document information. It's getting up to date about the document knowledge, and it's answering me according to with this knowledge of these documents. But this traditional one was like just, but this was the traditional flow where it was not aware what is in these documents and what is going on there. So RAG is basically solve this problem to update the LLM. So the RAG pipelines has mostly two parts: data injection and data retrieval. We need to understand them properly before we going to move into our hands-on coding project. So first, let's try to understand more basic about the RAG pipelines. Simply how the basic RAGs pipeline working. We are giving some documents, and these documents are stored into vector database. So this is RAG. RAG takes some documents that we put we saw that that's RAG takes that document. So it's stored those documents into some specific types of database called vector database, and we will see details about vector database soon. And it is stored there. When the user make a query to the RAG systems, it comes to the vector database. It takes the documents information from the vector database. Like the documents informations are stored already in the vector database. As we mentioned, that's RAG knows about the documents. And then it sends those informations, user query and the information from the vector database to the LLM. And the LLM generates the response. So in that scenario, the LLM has the user query and the information from the document. So the LLM is very good at reading and understanding and reasoning everything. So the LLM here has the documents knowledge, so it can produce the response now with the updated knowledge from the documents. So the most important part in this RAG pipeline is that's data injection. So this data injection is means how these documents are stored into this vector DB. That's the most important part. And before going to the hands-on coding, we need to understand this architectures and how it works, because yeah. So data ingestion process. So we can see here how it's going to work and how. So first we have some documents. It could be any kinds of documents, that's PDF, text, or HTML, like some readable documents. So will collect that documents. Then maybe there will be some processing the documents, like cleaning up text, cleaning up and reprocess. Like there could be some unnecessary informations or some symbol or anything. We like it's parsing about the importance data from the documents. That's we call cleaning and reprocessing the text. We'll do that, and then we will break down this documents into a smaller chunks, and these chunks are then sent to systems called embedded systems. Embedded systems uh, generate embeddings for each chunk, and these chunks are then embeddeds are stored in the vector database. So this is actually the data ingestion process. We take the documents, we collect, extract the text and clean up it. Then we break into a smaller chunks, and then we apply the embeddings. So the embeddings, what actually it does, it converts the text into some numeric number that we can directly save into vector database. So we'll go details now on a little bit about the embedding and vector database to understand actually why we need them and what they are doing. Before going, that's the text cleaning, why it's important. Like we can have different formats of text, like text can mislead the data processing pipelines. It could have some, like for HTML text, it could have some header, footers, or more irrelevant information. So we need to clean up those, like remove those unnecessary informations from the text, because they will make our system costly, because the more text I need to process, the systems will need to use more resources. And also like the irrelevant data could like pollutize my our vector, or like it could make it will make the processing pipelines it will make busy the processing pipelines, and unwanted text will always mislead the data and the response. And also there is one things, we try to normalize the fonts, like there could be a spacing, like you can understand there is irrelevant spacings or irrelevant symbols or anything into the text file that we must clean up or remove before starting the data ingestion processing pipelines. Now comes into chunk. What we do, as in the picture we see, like we first load cleanups and then we mix the data or split it into chunks. The chunks should be done like intelligently. Our accuracy of our rack system also depending lot of on this chunking. The size of the chunk is quite important, because it should not be large enough, it should not be too large or too small, because if it is it should be large enough to provide the context, and it's not if it's become too small, it will be enough to maintain the relevance for accurate retrieval. Also there is overlap strategy, like the overlap strategy try to create the similarity of between the chunks. So we will actually discuss this one when we will discuss the embeddings, the next topics. So we can see here after splitting, we comes for the embedding, and this one is the most important parts into that data ingestion pipelines for rack. What is embedding? Embedding is a list of numbers that represent full a meaning of a word or a sentence. So computer don't understand text, they can understand number and only binary numbers. But in for simplicity, consider here any natural numbers. So when we providing a text or sorry for the interruption, when we are providing any text to the computers, like if for the data machine learning modeling or anything, it turns that number into text into some meaningful numbers. That's actually called embedding, and the numbers are stored in database or machine learning model all in the embedding numeric values, because we cannot use directly text there, it does not understand the text. So let's take an example how actually embedding. Suppose I have a text leave policy and there is another text vacation rules. After embeddings, they both look like the leave policy look like an array of numeric like this, and the vacation rules look like a numeric array like this. And this is the embedding forms of these two text. And you will see leave policy and vacation rules, they are
Sorry, I
actually.
have to interrupt you. Your presentation isn't showing. Please share it again.
Oh, sorry. Somehow
It's
here.
okay.
Can you see my screen now?
Yes, you can continue.
Thanks.
Thank you.
Yes. So you can see there the leave policy and the vacation rules. Both two texts are embedded, and we have the arrays. They are similar words. You will see the numeric values of these two array are quite similar. Like they don't have much different. This means that these two texts are representing similar meanings or similar words. So this why embedding is important. It has its algorithms that convert those text into some numeric value, and for the similar text or similar words, the numeric values are quite close. So we'll not go deep details. That's how this embedding algorithm works and converts those text into numeric value. We'll just know that take the text and convert it into numeric values, and the computer can compare those numeric values and understand that's okay, these two text or these two words are similar. Now the problem is, if you take very big text, it will generate a long embedding array, and which will actually be hard for the computer. Like if the text is too hard, then it will be comparing those two embedding value will not make more sense, because there will be it will be long and it will be different. So if you break down the chunks into like the text into smaller chunks, then generating the embedding value and comparing those embedding values become more efficient for LLM or for like uh, for both about the vector database or the LLM models for everyone. So we need to be always uh, careful about selecting like the chunk size of the words when we are using them into the RAG or our LLM systems. Now comes to the point, vector database. So if we go here, we can see after embedding, we store everything in a vector database system, not in a traditional database system. We mostly use a vector database systems. And we need to understand what is a vector database and how it's different than a normal database and why we need that vector database. So vector is a special database that stores embeddings like the numeric vectors and allows fast similarity search. So in vector database, you can store those numeric vectors, like we are converting the text into embeddings or numeric array, and they can be easily saved into that vector database. And it can allows multiple similarity search. So we need to always do similarity search, as we see here. Like we have the leaving policy and embedding policy, and these two uh, the array are similar. So they meanings the similar meanings. So this can be searched. These types of search can be easily performed in an vector database. In normal database, it's not possible. So why we need in RAG store all documents and chunks in embedded vector database. So we know that RAG takes the documents and store it into the vector database to use it later for enriching the LLM's memory. So we need a database store for the RAG, and that's the vector database we use. The vector database user can ask the vector database quickly find most similar chunks, that's already I mentioned, and these chunks are given to the LLM for the accurating their answer. So this is how the process that's this is the ingestion process. We ensure we take PDF or documents, we clean up and we split them into chunks, The chunks are embedded, and after embeddings, they are stored into the vector database. And this is the data ingestion process, and this is the most important process that's we used in the rack pipeline. Now we will go the process that's called data retrieval. So this is the process how when user is questioning to the rack system, and it's giving us the response using the previous document, using the knowledge that it's also getting from the documents. So what's actually data in retrieval pipeline is doing, it's actually using the LLM and the documents I am providing to the rack systems. It's combined both of those informations, generating the response and giving me that response. Already the LLM is an smart model. It can interact with human. It's very logical. It can understand many things. But the limitation, it has the trained data. When I will give the LLM models, the data I getting from the documents, like the new data or some privacy data, or I have my own informations that's I want to provide my LLMs. So I am providing them, and the LLM is generating its response, combining with that document. So it's giving more smart answer. So how this flow is working, like users is making a query to the LLMs, and it's getting that documents chunking. It's getting that documents from the vector database, adding it with my query and processing. Then it's giving me the answer. So the now the answer is not only LLM's trained data, it's also have the data that it's also getting from the documents. So the data is being more appropriate, or it's having it's updating its knowledge with the data that it's getting from that documents. So actually, in retrieval pipelines, there are few things happening: querying, similarity search, retrieval, augmented modeling. I will go to the next one. That's what this is solving. Addressing changes. What is this RAG implementation is now solved? We can see that this RAG implementations is significantly decreasing the occurrence of hallucinations because it's verified the external sources. That's I'm providing data through that documents. It's have now some source of data, so it will not hallucinate. It will generate answer more reliable and accurately and up to date knowledge. So what is the up to date knowledge? Like that's a normal LLM model has some fixed train data, but with RAG implementation, I am giving it more informations, more resources. So it can use that resources, and it has the up-to-date data now. Suppose like about the weather forecast, I have I have a LLM model, and that's trained up to October 2025 weather data. And if I ask it about the weather forecast of November, first November 10, it will not able to tell me. But I can add it to that LLM knowledge based using RAG without training the model. So it will now, if I in RAG, if I added the documents that is giving the RAG LM model about the new weather forecast informations, it will be able to give me the answer about that November weather forecast. So it is up to dating the knowledge. So some real world RAG use case, knowledge like RAG enhance search accuracy for internal knowledge base. Like it's used by the financial reporting, like supporting financial informations for any financial company, different types of compliance doc. Like already LLM model has its best knowledge, then we can add any specific knowledge like the compliance doc, or different healthcare company is adding their healthcare informations, and using that RAG documentation over the LLM model, and it's generating more appropriate answer for them. So there are many like companies who are using customizing the LLM model using RAG and uses for their own purpose. Now I will go about I will move to that implementation, but before moving that, I will also want to discuss about some stacks, like what we are going to use for what we are going to do. We will make a intelligence systems that can read some informations from documents and update the LLM model. So we'll go for a basic React implementation today. But before going that, we will discuss something about the stacks. As I told about vector database, like there are a lot of vector database currently available in the market, like Easy Vector, ChromaDB, Pincon, Redis Vector Search. We can use any of them. And for the project, I will use Java. Java is actually a very powerful language, and Java for AI is also a good choice always, because we can see that Java is enterprise ready, very highly scalable language. Java has like large, stable, high traffic systems. It has like it is very production reliable. Then the benefits of Java has for AI, it has very strong ecosystem. Like Java has Spring Boot and Spring AI. So in Java, we can easily find APIs for rack systems, different kinds of vector DB integrations easily, and LLM feature can be deployed, and it can like it has frameworks like we can see Spring AI or Tribu DL4G. So they are like they have very good support in AI area. And performance about Java is always good. It has like it's very reliable in production. It can take heavy workloads, parallel processing, and high concurrency scenario effortlessly. And also the benefits of Java, it's very good for deployment. Like Java works smoothly with AWS, Azure, GCP. Java is very uh, famous and one of the most used language. Every like uh, mm, every provider, AWS, Azure, Docker has the support for the Java's enterprise services. And Java is also very good for integration with Python's AI model. Like whenever we are wrapping any like AI based model, we generally uses REST or gRPC, and to add those machine learning models into our web app. And Java is very good with using those REST or gRPC to communicate with the model. So Java is very good for integrating with AI models. Now, if we will use actually in our application Spring Boot. Spring Boot is what is a Spring Boot? Spring Boot is Java application development framework, which actually provide me common configurations and powerful tooling for creating Java application. So like if I try to build some web server, I need many configurations. I need to configure the server like Apache Tomcat and everything. When I will use the powerful framework like Spring Boot, I don't need to coding for them. I will get them automatically. And now comes to the picture, Spring AI. Spring AI is also a framework like the Spring Boot, but it's mainly focused on AI. Spring AI is a Spring framework that makes easier in Java to integrate AI and LLMs into Java applications. Like it provides simple API for chat. Here, chat means chatting with the machine learning model or the LLM model. Embeddings, RAG, vector database supports, they are already integrated with the Spring AI. So it's allowing developer to build powerful and quickly using the similar Spring pattern. Now in Spring AI in our project, we will use two major important feature. One is chat client. What is the chat client? The chat client is a component that can make real-time interaction with the LLM model. Like this chat client is a client that we will use, simply we will use in Spring we get from the Spring AI, and this chat client can communicate with LLM models. Like using this chat client, we can uh, communicate with the OpenAI or Gemini or anything. So the Spring AI already giving us an chat client. We don't need to implement our chat client, and we can use that to connecting with that AI models. And also the Spring AI gives us embedded client. As we have already discussed a lot about the embedded, what's embedded doing, like it's converting the text into numeric array, and we don't need to implement our own embedding systems. The Spring AI is giving us an embedded client, and that will convert our text into that embedded embeddings, like into that vector data. For the vector database, it will converting them into that vector text. So so we can see that Spring AI is giving us a lot of APIs that we can use, and that will make our development quite easier. So now I will actually move to that building our intelligence document system. So I want to go for the coding now. So first of all, I will go to Spring Analyze Initializer. It's an Spring, like here we can define our project configurations, and Spring will generate the project for us, like the basic what we need. So the project, we will use the Maven. Maven is used by Java for dependency management. So I will not go for the details, but what Maven does, whenever I am setting up a Java project, if it has any dependency it needed, all the Java packages are packages are managed by the Maven. It will download all the dependencies. And I am going to write my project into Java language. So I have select here Java, and the Spring, I have defined various Spring framework version for the Spring, like Spring Boot. I am adding that choosing 3.5.7 here, and it's okay. I'm keeping its name code example, and artifact's name is demo. I can say it's demo rack, demo project for Spring Boot, demo project for it's not I'm for rack implementation. And the packaging, okay, and the packaging will be jar, and configurations will take properties not YML, and I will selected Java 21. So I will need some dependencies here. So I will take Spring Wave. Actually, what is Spring Wave? You can see here it's built It's a help build web, including RESTful application using Spring MVC, and uses Apache Tomcat for the default as the embedded component. So I will take Spring Web, and I will also take OpenAI. So this is the OpenAI, and that's actually coming from the Spring AI. This is the Spring AI support for ChatGPT and all the language model and imagination model from the Open API. So if you want to see in Explorer, you can already see it has generated the project configuration for me. So what this Spring Initiative is actually doing, it's configuring my project and nothing more. I am selecting only the dependency and packages that I need, and defining the Java versions and the Maven versions. So you can see here, and you can see my dependency I have added here. So I'm just here now. I can start actually generating the project. So it has generated. Let's save it here. So once it's done, I will. So I have downloaded it. Now I will extract the project. So I want to open this project into my IntelliJ. So here is the IntelliJ. I'm actually for coding. I'm using the IntelliJ, and I have just opened this project here, this demo rack, and now I will create the project here. So here we can see this is the dependency of my project, and this is the source where we have defined everything. And you can see there is two folder. One is resources, where I will add all the resources, and there is the my Java coding and classes are here. But now what I will do, here I have, you can see I have already a text documents that's called policy text documents. So what is this text document? This text document is have some random company policy written. So I will use this text document into my rack injection pipeline, that it will be consumed by my rack system and will be stored into the database in vector database. So let's me going back to the IntelliJ. So first of all, I will come here and I will create a configurations file here. And here this file I will tag it as an configuration file, and now I will write the configurations. So first of all, I have that's policy. Actually, I need to copy this policy and I want to put it into this resource folder. Yeah, so text. So this will be that policy that will be consumed by my rack system. So actually, this is that policy.txt. This is that policy.txt. That's will I will this is that document that's my rack will consume and setting to the LLM model. So now going back to configurations, I need to take that resource and it's like, so you can see I have already this is a type private, this is the resource types that's actually coming from that Spring framework, and it's defining any resources from here. So it's actually already coming from that Spring framework, and I'm naming it as policy. And I am adding here, I want to, in this resource policy, I want to set this policy one. So it will be value, define the class path. This will be policy dot text. So we already added taking this policy here, and now we also need the vector store. Like we have this, we are taking this policy and we need to store this policy into vector store. So I have seen there is a lot of options available for the vector store. For here, I am not going to use any actual vector any complex vector store. I am going to use the simple vector store here. That will store this policy documents for me, and like after converting the policy documents into embedded string, I will store them into a simple vector store. So let's add the simple vector store here. Simple vector store, it's not added here. I need to add the dependency. Let me check in which dependency it's coming from. I will open the file. I have Spring Boot model open AI. I have to add the dependency and it will be Spring AI and artifacts will be Spring AI factories will be so I have to, as I am adding a new dependency, I need to go to Maven and reload the project. Reload Maven project. Now I will go back to the configuration and maybe this time I will find the simple vector store. It's not added yet here. Let me import it. Import this. So this is the simple vector store. It was not loading automatically, so I just added the import here. Now I will get the simple vector store. You can see here now the simple vector store, and now I will create the configurations for connecting my simple vector store. And I will add it bin tag here. What bin is being bin, we will added this simple vector store, this method into that dependency injection about of Spring AI, and when the simple vector store will be called, it will call this method, or it will create it for, it will inject this method as in the dependency. Now I will go for the simple vector store. Second. My vector store, it will be simple vector store, creating my simple vector store, and into the simple vector store I need to pass the embedding model. That's you can remember about the embedding that's we used for embedding the text into numerical values. So I am adding here the embedding models. will be that's embedding model. That's the simple vector store will use here, and I need to pass vector store. It will be to create the simple vector store. And I will need to pass that's embedding model, and I need to build it. So sorry, this is my vector store. That's this one. So this is my simple vector store, and for the simple vector store I need to give a locations where these embedded files. I'm saying I am not using any database, vector database. I am using simple data vector store. So it will, I need to give a location where it will take this policy text and convert into embeddings and stored in JSON format. So I need to give a location. So I can give it to the, so it will be vector store file. It will be a file type, and I need to import the file, import class, and I wanted to keep this location. So copy this path. This will be new file. Sorry, yeah. So it will be user and I wanted to give my vector store dot json. So what I'm doing, I'm defining a file where I will convert this policy text and making it into vector, convert it into vector or embeddings, and will save into vector store JSON. So it will save it in this folder. I see there is no this folder here. So I need to, I want that's when I will run the project, it will uh, create the vector and will save into vector store.json. So, and this will be in this resource folder. So I need to write for that. So it's here if this vector file does not exist, if this vector file exists, I will print that it exists, and if don't exist, I will generate it. And so if it does not exist, exist. So here I will write file exist, loading it. So this is my vector store and I will add this file here. So what I'm doing, this is the vector store file. If it exists, I am adding it to my sample vector. So what is this file having? This file is having the converted embeddings. That's I'm taking the policy now. What I'll do, if this does not exist, I will take the policy text, will apply embedding and save it into the vector stores. So system. So it does not exist. I'm creating it. Now, first of all, I need to take that's policy, that's have policy text, and I need to apply the tokenization or the embeddings on it. So for that, I will need a text reader because this one is a text file and I will try to read, I will read the text. So I have created a text reader that's actually will this policy text file, that's actually this policy does text. Now I will apply embedding on this. So for reading, for here I will need to set get custom data and I need to say the file name and it will be policy text. So this text reader will take this and in file name it will be use the policy dot text. Now I will convert this text into documents and it will be this AI document and that's it is coming from that uh, Spring AI and that will be used for tokenization. So here the documents I am reading, taking into the text reader. Now I need to split this text. So I will create a text splitter and I will do the text splitting for tokenization. So I will use token text splitter and now I will documents. So it will be list documents. This will be so I have splitted the documents using this uh, token text splitter that's actually making it into chunks, like the text in the AI model are when split into chunk, they are called token, and I am using this token splitter that's coming from Spring AI. So it will automatically do that token splitting and will apply embedding for it. Now I will added them into vector store. So I will go vector store. I have the vector store already. So I will add these splitting documents here and I will save it. And here I will return the vector store. So till now, what I have done here, I have taken this policy text and then I am creating the vector store. The text will be converted into vectors to JSON. That's the embedded files, and they will be here in a locations. If this file exists, load it. If it does not exist, take this policy text file, convert it, split it documents, and save it to the vector store. And this it will be saved here in this vector store. So now I will go to write a controller. That's I will added this, like I will create a controller where I will use the chat client to communicate with the open API, and let's move there, and I will add it there the my vector file. So sorry, I mean it's controller, so I can say it's policy controller. I again try to name it as config. So this is my policy controller, and I will use the REST API controller. So I name it REST controller, and in this controller I will create some Java controller. So first of all, I want to communicate with the Open API. I will say that I will have the machine learning model as Open API. So, and I mentioned earlier that for communicating with Open API, the Java Spring AI is giving me already the chat client. That chat client is already integrated with here, and that will be used for uh, chat with that open API. I don't need to do anything here. I will just import. You can see this chat client is coming from Spring Framework AI. That's I will inject here. So go. So I have built my like adding my chat client, adding into the dependency session that's already initializing in the constructor that's provided me by that Spring AI, and now I will use this one to create the controller. So now write my controller public string. As I'm chatting, it will give me response in string. So I will say it's policy Q&A. So basically I will question and answer about the policy, and you see here I'm adding some new policy. So I will question and answering about this new policy, and that's my RAG model will be able to answer me about this. So I am applying get mapping. I can say it should be only slash something policy. And the controller when will hit, I will have some message, and this message will be, I will pass this message to the chat client. It's message, and if I don't send anything, I can set here a default value. Need to map here. If I don't provide any value in message, I can say give me the default policy. This is my request parameters, and now I will have string my message. So I will have this message from the user input in my API. If this message does not exist, I will have this default message. Now I will ask send this message to the chat client. So it will be chat client dot prompt users. So this is the message that's user is giving this message to the chat client, and then it will call, and then it will then give the response, and that will be returned. So I will return the response. Now,
Sorry for interrupting you again. It's 1:15, so we have next speaker. We have to prepare, so
yes, okay. So should we finish? Actually, it's already here. I just
you
created.
need to bring presentation to an end. If that
Okay, so can I get 1 or 2 minutes more to wrap up everything? Hello, can you hear me?
can you hear me?
Yes, can I get 2 minutes to wrap up everything?
Yes, you can. And thank you.
Yes, so for yeah, here I have created the everything's. I am getting the message and I am asking to the chat client for the message. But one more thing I need to do, I need to edit that's policy documents that I get from here. Just give me a moment. This is I need to give set up these policy documents. It will be like I need to set up some advisor and I need to add the, I'm not going for the full details here. I need to add this advisor here and I will add that as default chat advisors and add I will add this advisor and then I will be able to run this project. And when I will run this project, it will create here a vector store and it will ask, but it will also, let me run the project. This will also ask for the open API keys. If I go just commenting out from here, sorry for being late. If I run the project, you can see open API key must be set. So actually I have to set up my open API key and it will be set up here. This will be something. Then API key. And once I will set up the open API key, my project will start running. And for the open API key, I mentioned that I am using open API, so you can collect the open API key from. Let me show you. So you can go to the open API and you can get the open API case from here and you will just add this open API key here using the environment variable and then you can run this project. So I have set up the open API key and you can see now this error is gone, but I have to also set up the chat model. I have to also set the and I will use GPT-4 and this is all from my side. You will set up this case and you will run. So this will take this policy documents, contact with and take from the vector is it at store it in vector store and we'll communicate with the chat client and the chat client, the OpenAPI will update it about that policy and it will give you response according to that. So this is from my side. I try to implement a simple RAG implementations And hope everyone enjoyed it, and thanks for joining the session.
Sumit, thank you for an interesting presentation. We will have a short break now and continue with the program at 13:30. Thank you again.
Okay. Thank you.
Bye.
Thanks for inviting me.
You're welcome. Thank you.